Hello, and welcome to Investigative Math. Today, we'll be learning how to use numerical factoring on the number sense test. So let's get to it. Alright, so to understand factoring, we first have to understand the opposite of factoring, also known as the distributive property. Did I spell that right? Yeah, okay. The distributive property. So, basically, you probably learned about this in 5th or 6th grade, depending on your school's curriculum. If you have an expression like this, 6 multiplied by x plus 3, then this is the same thing as 6x, 6 times x, plus 6 times 3. And the way I like to visualize this is imagine you have like a box composed of a square, not composed of, but inside of the box there's a square, which will represent our x, and 3 dots, which represents our 3. Now, if we had 6 of these boxes, we would have 6 times as many squares, and also 6 times as many dots. So you would end up with 6 squares, i.e. the 6x, and 6 times 3, or 18, little dots, and that's where we get our plus 18. So this factoring thing, numerical factoring, is just the opposite of the distributive property. So imagine we started out with 6x plus 18, and we wanted to turn it in to this right here. So what you want to do is look for a common factor, because here we took this number and multiplied it by each of these. So what we're going to do is the opposite of that. So a common factor of 6x and 18, a pretty standout one would be 6, right? So when you factor that out, just think, what multiplied by 6 is going to give me 6x? And that's obviously x. And then what multiplied by 6 is going to give me 18? And that's 3. Notice how this is basically the exact opposite of the distributive property that I showed earlier. So now we can use that on our first question. So we have 45 times 22 plus 45 times 23. So obviously we have a common factor of 45 in both of these expressions. I'm going to refer to its individual things that are being added as expressions. So in this expression and this expression have a common factor of 45. So let's try factoring that out. So 45 is what's going to be on the outside. And then if we were to take away 45 from this expression, you would end up with just the 22. Or sorry, divide 45 out of this expression, you'll be left with just 22. And if you divide 45 out of this expression, you're going to be left with 23, which kind of makes sense. If you have 22 of something and you add 23 of something, you're going to end up with 45 of that something. It's pretty intuitive, if you ask me. So this expression in and of itself needs another trick, and you'll notice that with factoring questions on number sense. Usually you have to factor it and it leads into using some other trick. In this case, we have to use the bump it trick. Now, I've made a video about the bump it trick and I will link it in the description below. So if we want to do this kind of problem, first, to recognize bump it, the 1's digits have to add to 10, and the 10's digits have to be the same. So 5 plus 5 obviously adds to 10, and 4 and 4 are the same. So the first step is to multiply the 1's digits. 5 times 5 is 25. And then we write that down. Then this is where bump it gets its name. We're going to take one of the 10's digits and bump it up by 1 to get 5. 4 goes up to 5. And then multiply that by the other 10's digit. 5 times 4 is 20. So 45 times 45 is 2025. So to recap, basically what you want to do is take out, here, give me 1 second. You want to take out a 45 from each of our expressions and then add them back, basically. So you take a 45 out of 45 times 22, you just have 22. And then a 45 out of 45 times 23, you get a 23. So if you have 22 45s and you're adding 23 45s, you're going to end up with 22 plus 23, 45 45s. Once we add this together, we get 2025. Sorry, once we multiply those together, we get 2025. Okay, for our next problem, we have 31 times 20 minus 31 times 18. So this is basically the same as our last question. The only difference is this is now a minus. So how do we deal with this? Well, first we have to find our common factor. So obviously 31 comes out of both of these. So if you factor a 31 out of 31 times 20, you're left with just 20. And if you factor a 31 out of 31 times 18, or excuse me, negative 31 times 18, you're left with minus 18, which makes sense. You have 20 31s, and you're going to end up taking away 18 of those 31s. So you're just left with 2 of our 31s. 31 times 2 is 62. So 31 times 20 minus 31 times 18 is going to leave us with 62. And that's it for using numerical factoring. Now that you have an idea of how to do this kind of question, I have provided a problem set in the description of this video for you to try couple for yourself. If you need me to clarify anything for you, leave a comment and I'll get back to you as soon as I can. If you enjoyed this video and found it informative, leave a like. And if you really loved it, make sure to subscribe. I'll see you later.